Okay, let's work on finding the domain of a couple more expressions. Let's talk about g of x. Remember, we have to make the differentiation if we're trying to find the domain between whether or not we have an even root or an odd root. So g of x, what would we say? Well, whenever we raise something to the 1/3 power, remember that our definition states that if we have x to the 1/3, it is the same thing as the cube root of that base, so it is an odd root. If we have an odd root, the rule is that the domain is the set of all real numbers. A very simple rule, but we'll write it down that way. Okay, so x would be in the set of all real numbers. All right, how about the next one? Well, this is just like in our last video. In this case, our quantity 16 minus x squared, x to the 1/4, pardon me, is the fourth root of that quantity 16 minus x. And so what we're going to say is that this is an even root, and we're going to use our even root rule. So what's going to happen here? Well, in this case, we're going to take the quantity 16 minus x. The rule is that we have to set that quantity greater than or equal to 0 to solve for the domain. Well, in this case, let's subtract 16 from both sides. So we'll get negative x is greater than or equal to negative 16. And dividing both sides by -1, remember, if you divide or multiply by a negative on both sides of an inequality, what happens? That's right, the direction of this inequality flips around. So it's x is less than or equal to 16, and we would write either the set of all x such that x is less than or equal to 16 in set builder notation, or if we were asked to write this in our interval notation negative infinity this time, to positive 16. Positive 16, not some funky looking pi thing, 16. And it's a square bracket around the end right over here. I'll try that again because I'm having so much fun. There we go. All right, so another couple of quick examples on finding that domain. More in the next video.